All right, Introductory Algebra Homework 38. We are solving rational equations that simplify to a linear equation. A rational equation means it has a fraction in it. And anytime we have a fraction in an equation, usually the first step is to get rid of my fraction by multiplying by my common denominator. In this case, the only denominator I have is 8x, but I have to multiply every term by that common denominator. So I'm going to multiply by 8x here, by 8x here, and by 8x there. So 8x times 5 would give me 40x equals, here with my fraction, I'm going to be able to cancel that out of there. So I'm just going to get the numerator 3. Plus 8 times 8x would be 64x. So now I have my regular linear equation, which means it doesn't have any more fractions in it. I need to solve it for x. Normally I like to put my x's over here on the left side, my numbers on the right, so I'm going to go ahead and subtract my 64x. 40 minus 64 would give me negative 24x equals, here I've just got my 3 left. Then of course the last thing I have to do is get rid of my coefficient. I get rid of the negative 24 in front of my x by dividing. So I'm going to divide by my negative 24 and simplify my answer. The negative is going to go out in the front because I have a positive over a negative, which is a negative. I can reduce. 3 goes into here once and into here 8 times. So negative 1/8 would be my answer in simplified form. Number 2, same kind of thing. I have 11 over x equals 24 over x minus 16. First thing I want to do is get rid of my fractions. I want to do that by multiplying by my common denominator. Since both of these have a denominator of x, x is going to be my common denominator. So I'm going to multiply every term times x. Here on my fraction I can cancel the x out, so I just get the 11. Here on my fraction, I can cancel the x out. I just get the 24. Here, I don't have a fraction to cancel, so I'm taking negative 16 times x, so I get minus 16x. On this one, I'm going to move my number over here. Since I don't have a variable on the left side, I could move the 16 over and then the 11 over and do 2 steps, but it's a little shorter if I just move my number over. So I'm going to minus my 24. 11 minus 24 would be negative 13 equals my negative 16x. Then again, I've got to solve that. I've got to divide by my coefficient, which is the one in front of the x. So I'm going to divide by my negative 16. A negative divided by a negative is a positive. I can't reduce the 13/16, and so x is equal to positive 13/16. Number 3, same kind of thing. I've got a rational equation, which means there's fractions. I want to get rid of the fraction. This time I have a denominator which is y and a denominator which is 2. Just like if I had a 2 and a 3, I'd say 2 times 3 is 6. Here I have to say y times 2 is 2y. So I'm going to multiply every term by 2y. So here I don't have a fraction. 2y times 4 is 8y. Here I'm only going to cancel the y out of there. The y's cancel out. I'm going to have 2 times 6. Trying to write my plus sign down twice. I'm going to erase half my stuff. So plus 2 times 6, which is 12, equals over here. My 2's are going to cancel out, so I'm going to get 5y. So 8y plus 12 equals 5y. Again, on this one, I'm going to move my variable over here since I don't have numbers on both sides. So I'm going to go ahead and subtract my 8y to move that to the other side. 12 is going to equal negative 3y, 5 minus 8. And then, of course, I have to divide by my coefficient. A positive divided by a negative is a negative. So negative 4 would be equal to y. number 4, 5, and 6 are finding unit rates. Dollars per hour. Pounds per dollar. When I'm finding a unit rate, the important part is the order of the question. It says, Greg bought 14 pounds of flour for $8. How many pounds did he get per dollar? How many pounds, 14, did he get? The word per in algebra means divided by the dollars. The dollars were 8. You're going to use your calculator, and we're going to round to the nearest hundredth if necessary. So I'm going to go ahead and grab a calculator here. If I do 14 divided by 8, I get 1.75. It says round to the nearest hundredth, where it already is in the hundredth place, so I don't need to do any rounding. 1.75 pounds per dollar is how much flour I get. Part B, it takes 38 pounds of seed to completely plant a 7-acre field. How many acres can be planted per pound of seed? So how many acres is the 7 can be planted per pound, so divided by the number of pounds, 38. Acres per pound, 7 divided by 38. It's got to be in that order. So 7 divided by 38 on my calculator gives me 0.1842, it keeps going and going and going. I want to round to the nearest hundredth. The hundredth spot is 2 places after the decimal, so I want to either leave that an 8 or round it up to a 9. Since there's a 4 behind it, we leave it an 8. If it were 5 or higher, we'd round it up. So we're going to have 0.18 acres per pound. By the way, again, on the ALEX program, if you don't put the 0 in front of that decimal point, they're going to remind you it's correct. However, it's prettier, even on your calculator, the 0 will show up. So you want to put that 0 in front of your decimal. Number 5, going to be the same kind of thing. Let me move that up so we can read both parts. It says at Davidson's bike rental, it costs $23 to rent a bike for 4 hours. How many dollars, 23, does it cost per hour for 4 hours? So again, dollars per hour. $23 divided by 4 hours. 23 divided by 4 is 5.75. That is already to the nearest hundredth, so I don't have to do any rounding. $5.75 per hour to rent my bike. Lucy bought 20 pounds of sugar for $12. How many dollars, 12, did she pay per pound of sugar? Divided by the number of pounds. Dollars per pound. 12 divided by 20. So 12 divided by 20 gives me 0.6. And again, this is in the 10th spot. It says round to the hundredths, but since I don't have anything in the hundredths, I don't have to go any farther than the 0.6. Number 6 is going to be the same kind of thing here. So I get the board moved. It says Chris runs 9 miles in 56 minutes. How many minutes does he take per mile? How many minutes, 56, does he do per mile divided by the 9 miles that he went? So 56 divided by 9, I get 6.222222, and the 2's keep going. Rounding to the nearest hundredth, I'm going to do 6.22 since I don't have to round it up. At Keller's Bike Rental, it costs $45 to rent a bike for 8 hours. How many hours of bike use does a customer get per dollar? How many hours first? Per dollar. So 8 divided by 45. 8 divided by 45, I get 0.17777 and a whole bunch of 7s. Again, I'm rounding to the nearest hundredth. Since there's a 7 behind that 7, I got to round it up. So 0.18 hours per dollar. So always look here, hours divided by dollars, minutes divided by miles when you look at that question. Number 7, we are now going to do a word problem on proportions. You've already done word problems on proportions in the review section. They're just kind of reminding you because later on we're going to do some longer and harder word problems on proportions. But we use a word problem on proportion when we have something called direct variation. We'll talk about that again later. Direct variation means if I increase one thing, the other thing's also going to increase. Or if I decrease one thing, the other thing will also decrease. So the more miles I run, the more time it's going to take me as an example of direct variation. It's going to give you a rate. Bob runs 3 miles in 25 minutes. That's my rate. At the same rate, how many miles would he run in 60 minutes? I want to make sure my miles are on top and my minutes are on the bottom. How many miles in 60 minutes? Now I put the labels there just so you could see how everything has to line up. When we solve a proportion, to remind you, we just cross multiply. I like to start with the x first because I like my x on the left side, but it doesn't matter. 25 times x would be 25x. 3 times 60 would be 180. So 25x equals 180. And then easy enough to solve, I'm just going to divide by my 25. Again, go ahead and grab your calculator to do that, unless you want to do it on your paper. If I divide that out, I get 7.2 miles then. If I can go 3 miles in 25 minutes, I can go 7.2 miles in 60 minutes. More miles took me more minutes, right? Number 8, same kind of thing. Raina drove 300 miles using 14 gallons of gas. So my rate, 300 miles using 14 gallons of gas. By the way, in your rate, if you flip that and put the 14 on top and the 300 on the bottom, it's okay as long as you're consistent when you do the other side of your proportion. At this same rate, how many gallons? So how many gallons would have to go on the bottom since I put my gallons on the bottom? Would she need to drive 375 miles? 375 miles. So again, notice my miles are on top, my gallons are on the bottom. And so now I'm going to cross multiply. 300 times x, 300x, and 14 times 375. 14 times 375, 5,250. So again, in order to solve this for x, I'm just going to go ahead and divide by my 300. Divide by 300, I get 17.5 gallons. So I went more miles, it's going to take me more gallons of gas. Just to kind of look to make sure, does that make sense? Yep, that looks good. Number 9, same kind of thing. Lamar runs, that's supposed to say runs. Let's fix that so it says runs. Must not have been able to type that day. Lamar runs 7 miles in 50 minutes. So, 7 miles in 50 minutes. At the same rate, how many miles would he run in 15 minutes? My miles are on the top. How many miles would he run in 15 minutes? Cross multiplying to solve that. 50 times x would be 50x. 7 times 15. Gonna be lazy. 7 times 15, 105. So 50x equals 105. Again, in order to solve that, we're just going to divide by our coefficient of 50. So 105 divided by 50 gives me 2.1 miles. 2.1. I can go 7 miles in 50 minutes, but I'm only going to go 2.1 miles if I go for 15 minutes, right? With less minutes, that means I go less miles. 10, 11, and 12, we are also going to solve by using a proportion. We have similar objects. If I would double one side on the shape, I'd have to double all of the sides on the shape. So again, we're going to start out by setting up a proportion. I like to set up my proportion using the variable I'm going to solve for. So in this case, I want to find x. X corresponds to 7 over on this shape. So x over 7 has to equal something else. I'm going to pick one of the numbers on the same shape as the x, since I started with the x here. Doesn't matter which one you pick. For example, I'm going to pick the 3.6. 3.6 corresponds to 4. So 3.6 over 4. If I solve that by cross multiplying, x times 4 would be 4x. 7 times 3.6. 7 times 3.6. 25.2. Again, in order to solve that, we just have to divide by the 4. X equals 6.3. Right? This side is just a little smaller than this side, then this side should be just a little smaller than that side, right? Now, what happens had I set up my proportion using one of those other numbers? Just for fun. I still would start out with x over 7, because x is the side I want, it corresponds with the 7. But what if I would have picked the 2.7? 2.7 corresponds to the side over here, that is 3. If I solve that by cross multiplying, 3x is going to equal 7 times 2.7. 7 times 2.7 is 18.9. If I divide that by 3 to solve that, guess what? X is equal to 6.3. I got the same answer both ways. It didn't matter. I could solve it a third way and put 1.8 over 2. I still should get the 6.3. Not that you have to do it 3 different ways, but to get the point across that it doesn't matter which side you pick as long as you set it up with its corresponding side. So, if we look at the next one. Number 11. Again, I'm trying to find the length of x. X corresponds to the 3. So x over 3 is going to equal. I'm going to pick one of those numbers and one of those sides to work with. Just because it's easy to draw an arrow, I'm going to pick the 4.8. The 4.8 corresponds with the 4. So 4.8 over 4. Cross multiplying. X times 4 is 4x. 3 times 4.8. 3 times 4.8. 14.4. I got to solve that by dividing by my coefficient of 4. And so x is going to be 3.6. 3.6. So here, it was a smaller number. It's bigger over here. Here it was smaller. It's a little bit bigger over here, right? 4 went to 4.8. 3 to 3.6. Number 12, same kind of thing. Number 12 is the last one on this page. Again, I am trying to find the length of x. X is this side here. X corresponds to 5. So x over 5 is going to equal, picking a number to use, I'm just going to use the 3.6 again because it's easy to draw my arrow so I don't have to go through the middle of my shape. So I'm going to use 3.6 over 4. If you wanted to, you could do 2.7 over 3 or 1.8 over 2. We all should end up with the same answer. Cross multiplying. X times 4 would give me 4x. 5 times 3.6. 18. So in order to solve this, I'm going to divide by my 4. And I'm going to get 4.5. 4.5. This side is 5. Here we got 4.5. This side was 4. It went with 3.6. And so forth. All right, that is the end of homework day 38.